The Rise in 3D Printing, prepared by James Shears Hubly. Table of contents, we're going to go over the executive summary, the introduction, the history of 3D printing itself, the first prototype of 3D printing back when it was invented, how 3D printers work, the different processes used for 3D printing, the future of 3D printing and what is possible for it, and then we'll have a wrap-up and followed up with the bibliography. The introduction for 3D printing. 3D printing has been something we're hearing about more often now than ever. How would you like to build anything you possibly could? It's a new revolution in the industrial manufacturing industry. Having a 3D printer in anyone's hands gives them the ability to customize any part, piece, or whole that they are looking to make. 3D printing objects from cars to operating hearts is possible, and the possibilities are ever growing now today. With the technology expanding, it is something that is greatly resourceful for us today. The summary of this PowerPoint will be looking at the information it shows in 4 general areas of study in the concept. There's the history behind how to create a 3D printer and why they are here today, how they work compared to traditional methods, and the different processes involved when 3D printing. Finally, we'll be looking at what the future holds for 3D printing. The history of 3D printing. 3D printing was invented back in 1987 by 3 companies that looked into how they could make prototyping faster. They were very interested and they used their resources to look into what would make prototyping a faster process. Back in the day, prototyping would take weeks and weeks to create. You would have to create a cast, then you'd have to make it, and then you'd have to have it shipped back for you, and that is all after you designed it and you spent weeks in preparation of it, and then you went to have it made for you and bring back. It would take almost a full month to have one prototype tested, and it could fail, and then you'd have another month just to do it. So this was created so that you could possibly print a prototype that day, maybe try one the same week, and when you're doing that, you're saving time, and when you're saving time, you're saving the company money. Making a prototype in a faster way so you can see what products do and don't work, you're really just testing innovation. How 3D printers actually work? It starts with creating an AutoCAD file in AutoCAD software. This is some technology that we have been using, and very many people use it today in our own building at NSCC. Some electronic engineers and along with some other trades use AutoCAD today, and they are unaware of the potential they have. Once the object is created in a CAD tech file, you can create a 3D home. Once this happens, you take it into another software where the software will slice it horizontally into 2D pictures when looking down. It's like looking at a floor plan for a house and then making each floor plan 1 inch tall at the time until you have a 30-foot tall house. That's how a 3D printer thinks. So once you put the file and create it and print it, then you send it to the printer so it can be actually printed. And the 3D printer does the physical process. The different processes for 3D printing. There's 7 different processes for 3D printing that have been invented over the years since '87. The most popular one that we'll see today, and that has made it more popular for most people, and you'll see in consumers' homes for individuals and not for industrial use, is material extrusion. That's the biggest one of all of them. The other 6 use different methods for using different materials and for getting different objects or prototypes is what they're looking for. So we have the vat, the material jetting, binder jetting, powder bed fusion, sheet laminate, and direct energy deposit. All of those except for sheet laminate and direct energy deposit and the material extrusion that we're talking about all involve a process where material is set in a tub and the 3D printer uses the material in the tub and it has a base in the middle of the tub. The base is where it starts to build, but the material rises as the 3D printer prints. It's almost as if you had liquid and then you were zapping the liquid as it rises in the places that you wanted it to stay. That's the idea behind most of them there. Material extrusion is pretty self-explanatory as it uses a different process. It's using the actual physical extrusion through a nozzle of the material into a 3D form. And sheet laminate is the compressing down to make one object thinner and compacting it on top of another object, on top of another object, until you have a full object. Now when we're looking at the future of 3D printing, the future is really how fast can we create things? What prototypes can we create? It takes the time and cost out of creating a prototype. So when Nike wants to test one of their new shoes, it used to take them 3 weeks to cast a mold, create it, draw it, send it to be made, have it shipped back, and then it fails. And then it takes another month for that entire cycle to go over again. This allows them to print an object today, watch it fail, and print the new prototype the same day with whatever minor adjustments it needed. There's very many other practices for this too, except for Nike making shoes and trying out different shoes colors. There's creating bolts and parts that you would only uniquely create, and you might have to create a metal cast, and it's very costly and very time consuming to create this. So when you have a 3D printer, you can test all of these prototypes very fast. And in some cases, they're printing not with just plastic, but human cells and creating human lungs and hearts. It's been done before now. That's the health side, and that's where the industrial side comes. You can see it in different industry uses for all sorts of different purposes. For health, in metal fabrication, you can use bolts. In manufacturing, for Nike, it's testing. And there's obviously more yet to come for the technology. The conclusion for what 3D printing really brings to the table is that time is money. And 3D printers save a lot of time, which in return saves a lot of money. And I feel like that's what the role is in 3D printing nowadays. That's what it brings to the table for most consumers. In the big picture, it helps people at home as a tool that they can use around the home, helping themselves. And in business, it's a larger tool on a bigger scale. And that's where the price point comes from too, from $200 to $10,000. It's just the scale of things. Here's my bibliography from where I got all my sources from. And that's the presentation for today. Thank you very much.